Okay, so from the question we basically get a couple points, which is what we know, and what we know is that he is 1 meter. Ryan Tannehill is 1 meter in the air after Patrick Willis hits him, and then he's 4 meters from the end zone. And he's flying at a 45-degree angle at 6 meters per second. So with this doesn't do us any good unless we find the components of it. So with that, we'll do 45 degrees and 6 here, and so this is opposite. This is hypotenuse, and from SOHCAHTOA we basically get 6 cosine of 45 is the velocity initial of the x, which happens to be 4.2 in this case. And since it's a 45-degree angle, both sides are going to be the same, and so velocity initial of y is also going to be 4.2. So now that we know this, we're going to make our table. So x and y here. Let's start out with delta x, delta y, velocity initial, velocity final, I'm going to run out of room, acceleration, and time. It's a little bit crowded. Let's make it a little, sorry about that. Velocity initial, velocity, acceleration, and time. Time for both we do not know. Time is question mark. Acceleration for x is 0. Acceleration for y is negative 9.8. Velocity final for y we also do not know. Velocity initial for y we do know, which is 4.2. And delta y is negative 1. Because he's 1 meter in the air and he's going to fall to the ground, which is 1 meter below him. Delta x is what we are finally looking for. That's our goal. Velocity initial for x is going to be 4.2 as well, and because there's no acceleration, it's also going to end at 4.2 meters per second. So now that we have our table, which looks ugly right now, sorry about that, but we'll plug it into the formulas, which are up here. So first, let's plug it into the third formula. It's going to work the best for what we're trying to get here. And what we're trying to get right now is the velocity final y, so that we can find out time. So velocity final squared of y equals velocity initial squared plus 2 acceleration delta y. So it's going to be 4.2 squared plus 2 negative 9.8 times negative 1. This equals out to 37.24. If you do the math, these equals velocity final squared. So velocity final, you square root both sides, and it's going to equal plus or minus 6.1. In this case, it's going to be negative 6.1, because that's the only thing that makes sense here. So that's the velocity final in the y direction. So now we can plug this back in to our table, and now that we have this, let's go to the first equation. So we know that velocity final and y is negative 6.1. The velocity initial is 4.2. The acceleration is negative 9.8, and the time we do not know, so we're finding the time right now. Okay, so subtract this. It's going to be negative 10.3 equals negative 9.8 times time, divide negative 9.8, and we get time equals 1.05. So boom, now we have time. So with time, we can find out how far Ryan Tannehill travels. So we'll plug that into the first equation, which is delta x. Ready? Okay, sorry the video cut off. Anyway, we ended with knowing that the time is 1.05 seconds, and we're plugging in here because we know the acceleration is 0 in the x direction. We can cross this out. So the velocity initial for the x is 4.2. The time is 1.05. Just plugging it in. And this comes out to 4.41. So delta x equals 4.41. And so the answer to the question is, did he land more than 4 meters away? And yes, he did. He landed 4.41 meters, which means it was a touchdown. Dolphins win the Super Bowl. So